We have 2 word problems today and they're getting a little bit spicier. So let's jump with the first one. The longer leg of a right triangle is 8 units. The other leg is the solution to 4x minus 3 equals 17. That solution is going to be important in our definition for this problem. What is the length of the hypotenuse? So first things first, notice they're letting us know there are 2 legs and we're looking for hypotenuse. I think that's important because a lot of kids might say the longer leg and might think that the longest side is 8. So just make sure you're being really, really careful as you read through these problems. And what do we want to know? We want to know what is the hypotenuse. How long is it in this problem? We know that the 2 legs are 8. And the other leg is whatever x is in that equation. So we have to solve for x. So we know our plan. We're going to use our Pythagorean theorem. We're also going to have to solve that equation. We have to figure out what x is. And once we have that, we'll be able to substitute for a and b, which will allow us to solve for c. So there's our plan. Hit pause so you can jot this down into your notes. All right, math marbles, I'm just making a visual just from our work, and I'm just putting in the legs of my triangle, and we don't know what the length of our hypotenuse is. That's going to be c. So let's start by writing our formula. A squared plus b squared equals c squared, and this one looks spicy because one of the sides is an expression, but that's okay. We know what a is. That's just going to be 8 squared. Let's work out the other side. So I'm going to start by simplifying this. 4x minus 3 equals 17. We know how to solve this out. So I'm going to add 3 to both sides. 4x is equal to 20. 5 by 4. X is equal to 5. Look at that. It was feisty and it ended up being x equals 5. So yeah, this side is just 5. The solution to that problem was 5. So let's put that in there. 5 squared is equal to c squared. And now we can just evaluate and go through this problem. 64 plus 25 is equal to c squared. Let's add these 2 up. And I get 89. 89 is equal to c squared. Let's get that c by itself by finding the square root of 89. And that is equal to 9.433. And we're going to round that to the nearest tenth. So 9 4/10 units. And there's our final answer, math marbles. Hit pause so you can jot this down into your notes. I love big flat screen TVs, so this type of problem was really good for me because you actually figure out the size of the TV by how long it is diagonally. That's how they figure out the size. So in this problem, a store advertises the size of a television screen, again using the diagonal measurements of the screen. We know that, I just said it. Here's the 2 things we're going to do. First, we know a television is advertised as having a 45-inch screen. If the screen is 36 inches long, so just on the bottom, the base of it, find the television's width. So we have 2 sets of information and it gives us a little hint to draw the diagram to help us visualize. And then once we have that information, we're going to find the area of the screen. Okay, so math marbles, what are we doing in this problem? We're going to do a few things. 1, they're asking us to find the width of the TV. That's it. Like, what is that leg of the right triangle, the side? And once we know that, we're going to figure out the area because now we'll have a length and width. We know the diagonal part of the TV is 45. So, of course, we don't use diagonal for area, but it is helpful to help us find the other dimension. And we know that the length of the leg is 36. So we just had to figure out whatever the other leg is for this problem. And we're going to use our theorem so we can substitute, in this case, B and C to figure out A. And once we have A, we're going to use that to find the area of the TV. Easy peasy. Hit pause so you can jot this down into your note and we'll put our plan into action. Just like in a previous lesson, we have a problem that has a rectangle and we're looking at the diagonal line, which does create a right triangle, so we can use this information to find the other side of this television screen. And this is again why Pythagorean theorem is super useful, because I can use it to find the side of a regular rectangle. So here we go. I've already put in one of the legs, and the hypotenuse, the diagonal, is 45, which means the other leg, I'm just going to call this A. And that's the one we're trying to figure out the width. So I'm going to write in our formula. And let's put in the numbers that we know through our substitutions. And I do not know 36 squared by heart, so let's just do this. 1,296, just using my calculator. I do know 45 squared, because I did a little trick as a kid. I always knew that any number with a 5 at the end, the square would have 25. And there's always something with a front. So watch this. 5 times 4 is 20. So those are the first two numbers. And that's the square root, the square of 45. And if you don't believe me, there you go, 20 to 25. It's a pattern I always noticed with square numbers that ended with a 5. Okay, so let's isolate just to get the A by itself. So 2025 minus 1296 is 729. A squared is equal to 729. And if you want to isolate and get the A by itself, I'm going to move this over. A is equal to the square root of 729, or 27. So let's put that into our final answer. The screen has a width of 27 inches. But we're not done. That just answers part A. Now we're going to use this information to find the area of the TV. So area of a rectangle's length times width. So we know our length is 36 and our width is 27. 36 times 27 on my calculator is equal to 972. And the area, I'm going to put this in context, is 972 inches squared. So there you go, math marvels. Hit pause so you can jot this down into your notes.